Dalibor Topic, and as you can hear from my name, I'm German. That means I live in Germany, up in the north, in Hamburg area, and it's always a pleasure to be here in the south because I was born not too far away from here. And for the past 10 years, I worked for Sun Microsystems, and then after the acquisition for Oracle, I still continue to do so in the Java platform group, and my title is something about a product manager, though it's a bit of a ironical title, I would say, because I don't really manage a product. I spend most of my time working on OpenJDK, and within OpenJDK, which is an open source community where developers from Oracle and across the Java ecosystem work together on the reference implementations of the Java SE platforms, the corresponding updates, and a whole host of other projects, for example, for features. And today's talk is going to be about the faster release cadence and how to adjust your processes and what tools you can use provided by the JDK to be able to upgrade with confidence. I'll have a talk tomorrow afternoon, I think at 5-ish, talking about the actual JDK 13 and 14 in these releases. So I won't be spending any time now telling you why you should be running JDK 13 because I can do that tomorrow, right? That being said, if you've ever seen a talk from me or from my colleagues, you know this slide. This is the Oracle Safe Harbor statement slide. I'll give you a moment to read it and enjoy it. I'll take a moment of water. In short, don't trust anything I say. Don't make any decisions based on it. Do your own research. Okay, and so let's start with the good news. Good news, everybody. JDK 13.01 is here. So last week, we released the first update of JDK 13. Just about a month after JDK 13 was publicly available. That doesn't mean when I'm talking about fast release cadence that you should be expecting an update every month now, right? The fast release cadence is only about the JDK major feature releases, we call them now, which come out every 6 months. But each one of those gets 2 corresponding update releases which address critical issues, like say security issues, on a quarterly cadence. And so when we release September, the next update then is October, and then 3 months later, 13.02 would be in January, and then 13.02 goes away, 14 comes along sometime in March, and so on, gets 2 updates. And so this cycle provides both rapid releases of the JDK for developers and users, but also provides critical updates for those users who use those you release in production so they can use them safely, knowing that the code is actually high quality and the critical issues addressed. As before, you can go and download the Oracle JDK from Oracle on the Oracle Technology Network, java.oracle.com, under the OTN license agreement. But as part of the faster release cadence, we also provide, since 2 years now, open source binaries of Oracle OpenJDK on jdkjava.net, so that if you're an Oracle customers, you can use the former. If you care about open source, you can use the latter. And most importantly, if you care about Docker, you can also go to Docker Hub. And last year, my colleagues from the Oracle Linux team collaborated with the maintainers of the official OpenJDK images on the Docker Hub. And then that means you can get the latest JDK 13.01 update based on the Oracle OpenJDK binary on top of Oracle Linux, straight from the Docker Hub with a corresponding tag. And that in turn means that if you're using Docker in production or using Docker in your CI lines, you can then slurp this in when it comes out. And all these things basically come out pretty much at the same time, so that you don't have to spend weeks waiting to then move on to the next build. So in that sense, you have a cornucopia now of options to get your JDKs as you move forward in this faster cadence, both as an Oracle customer, but also as a regular user who wants to just keep on this 6-monthly cadence. And this has been somewhat of a big change in the ecosystem, because the JDK used to take years to come out. And I just had a conversation earlier today where somebody pointed out that In fact, it would take years, and it wouldn't be quite clear which year it would be when it would come out. So the JDK release cadence was rather unpredictable up until JDK 10 when we started this cadence for real. And that made life harder for users to some degree, but in particular for tool vendors, because they could then not necessarily plan well ahead for next releases. So we've taken that into account and switched the whole thing on its head. So now we have releases that come out on time, almost like a Swiss clockwork, or maybe a Swabian clockwork, every 6 months. And those are available both, from Oracle as commercial releases, but also as free and open source releases for Oracle OpenJDK and other distributors. But then we also offer for those customers who prefer to stay on a version for a longer period of time, long-term support versions. And these are also available both from Oracle as well as from other parties. And this means that there are different migration paths. There is this faster release cadence where you can adopt new features quickly as they come out, which allows us to release them to you, so you get better performance, you get new capabilities in the runtime, you get new language features, new APIs, but also means that more conservative users can keep their investment safe for a number of years and then migrate to the next LTS version, for example, depending on their own requirements, budget, plans, and so forth and so forth. And I think these two paths have been actually quite successful now. We've done it for 2 years because they allowed both us and the JDK team to deliver innovation now to users and developers, but also had some really nice side benefits. One of those is that when you look at how users adopt those big JDK releases, in the past, they were not just taking long, but they were also big in scope. And one way to measure scope in the JDK is something called jdeps, JDK Enhancement Proposals. JDK 8, for example, had lambdas, great, but it also had almost 60 other features in there, which were also quite big in scope. And that's a lot of stuff to digest. If you're a tool vendor, if you're a user, you'll be going through release notes, and maybe you'll find of the 60 things that there is 2 or 3 or 5 that may affect your code that you may need to adjust for. And so you may, take a more reserved stand about adopting this release right away. JDK 9 was, in that regard, an even bigger release because with Jigsaw and other features, it had even almost 90 jdeps in its scope. And so accordingly, you would look at release notes and say, well, maybe not just right now. And in network theory, this is called the penguin effect. So all these penguins are together on the ice shelf, and there is fish in the water, but also predators in the water. Whoever jumps in first may get the fish, but may get eaten. So you want somebody else to go first to make sure it's safe for you to go after them. Which is why, with bigger releases, people tend to wait for a bit to see if somebody else gets hurt or, what the effort is necessary. With the 6-month cadence, there isn't enough time to squeeze in 90 features in there. So by definition, their scope is much smaller. And on average, they have around 10 jdeps per release. And that means that amount of risk, so to say, of moving from one release to the next is much, much lower than, say, with something that's 6 times as large. It doesn't mean that, going from one LTS to the next, it's going to be a different kind of effort because 10 times, 6 until the next LTS is still 60 jdeps. So you still look at the same kind of effort. But it does mean that you can do this migration effort on a more predictable and budgetable basis. You can, plan for it every 6 months to go from one release to the next, and it's a reasonable amount of effort rather than a big migration project every 3 years. And so what we have found as we've worked with open source projects who've started to, look into running and building on 11 was that once they got there, being able to move to the next and next and next release wasn't nearly as hard as, say, the initial jump from the hurdle from 8 to 11 was over across the big bar 9. And so, like I said, penguin effect, we basically, with the faster release cadence, make it easier for everybody to go from release to release with less risk. But we know it's not for everybody. If the water is too cold, there are support options from Oracle, from others, no worries. So in this talk, what I really want to do is I want to focus on the means we provide in the JDK to let you evaluate whether your code base is ready and your dependencies are ready and how to go about it. And the first question people ask in this context is, okay, so fine, I have an application I want to move to the faster release cadence. Cool. Is it going to build? Will I be able to run my tests on it? Will I be able to use my IDE to develop code for it? And like I said, we've been doing this faster cadence for 2 years now. So we have some amount of experience with how the adoption of this cadence in this core components of the ecosystem has been. And the most important thing to take away here is that you should keep your tool chain always up to date, because that means upgrading to latest releases, because they will typically have fixes and enhancements to work better with the features in new JDKs. But that being said, if you're using the latest version of Ant, or using the latest version of Maven, or the latest release candidate of Gradle, you can basically use JDK 13 or 13.01 to bootstrap those, to build them themselves, so they'll work just fine. Similarly, test frameworks or IDEs such as Eclipse IDE, or other IDEs using components from Eclipse IDE like the Visual Studio Code also work and support features from JDK 13 by its release. Popular frameworks such as Tomcat, or more enterprisey stuff such as Spring or Webfly also tend to announce support for JDK releases pretty much within weeks of its release. So for example, I think Spring just announced support for 13 about a week ago. And the list goes on and on, development tools, monitoring tools, and so on and so on. So there is a significant chunk of the typical tool chains people use to develop applications that already is following the faster release cadence, or is ready for it. So that you can, when you ask the next question is, okay, great, but I have also additional libraries I use. What about those? Can they keep up with a 6-monthly cadence? There the answer is typically going to be yes, as long as they're within this big blob of Eclipse, NetBeans, Spring, Wildfly, and so on. They tend to work well with this cadence as well, simply because as dependencies of these larger frameworks and projects, they also get tested and integrated in time to work with the next release. If you go outside of the mainstream, though, it can be challenging, in particular if the library in question, say, tries to do some bytecode manipulation tricks or something like that, because the JDK class format changes from one JDK feature release to the next. Every 6 months, the class file version gets updated. And so that means if you rely on a tool or a library that somehow munges bytecode or does something fascinating there, it too needs to be able to update its bytecode reading or writing functionality every 6 months to be able to generate corresponding bytecode for the latest version, or to read it. And that can be problematic if the library you rely on doesn't get updates often enough. Let's put it this way. So if you're, if you have a 6-monthly cadence of releases and the library you're using only gets an update every 3 years, then you may have a problem there. Because if an issue shows up with this library, then you may not be able to get it updated and fixed in time for the next release in the cadence. So in short, if the last time some library in your code has been updated has been before the Brexit referendum, you should probably take a second look at it. There may be a better alternative by now, right? Good signs when you're using library is that they're documented, for example, to work well on JDK 11 or later, because like I said before, the hurdle from release to next is then much lower, and so the risk is much lower. It has frequent releases, and we've seen with IDEs like Eclipse or IntelliJ or even Wildfly that have come down to a quarterly or 4-monthly release cycle, which plays well with this JDK cadence because it allows them to have 2 updates within a single JDK release to both support its features and, expand on them before the next one comes around. And last but not least, participates in something called the OpenJDK Quality Outreach. And this is potentially somewhat obscure. This is something we started to do a couple of years ago, where we are now talking to more than 100 different popular open source projects and their dependencies. Every couple of weeks, we inform them through the OpenJDK Quality Group about new early access builds, provide them with summaries of potentially relevant changes in those JDK builds, assist them with filing issues in the OpenJDK bug tracker, and getting those to the right people to look at, ask them to provide feedback on specific new features that may affect them. And of course, they're not expected to test every single build, but our experience has been that they tend to test enough builds so that they can be confident that their code then works well from release to next. And it's pretty easy to sign up. There is a mailing list, Quality to Discuss, and OpenJDK. You can ask me if you want to join. And you can find more information on the OpenJDK wiki about that. And the reason I mention that is that, first to say thank you to those of you within Eclipse who already participate, and to encourage those of you who don't to consider doing that. And the second reason is that I had a conversation with one of the gentlemen from Eclipse Collection, with Nikhil, one of these great participants up there. And Nikhil does a lot of good work to ensure that Eclipse Collections works well with each new JDK release. But also he pointed out in a conversation that he's increasingly seeing users and developers look at this quality outreach as a source of information for what libraries can I rely on in this fast release cadence. What libraries are really ready for me to adopt when I'm writing code that's moving along every 6 months. And so that too, I think, is a good motivation to consider adding your project to this roster and, running some tests of the JDK access builds with your own code. And that's pretty much a secret sauce of moving to a 6-monthly cadence, is that you need to be able to build on the release you ship on, and at the same time test on the release need to be running on 6 months from now. And so, for example, today you would be running on 13, for example, and you should be already starting to think about testing on 14, because 14 is coming down the pipe a couple of months from now. Now, it doesn't mean you have to compile your code on those builds, and this is a bit of a maybe subtle distinction, but a relevant one. You need to differentiate between 3 JDKs. The JDK you use to run your build tool, the JDK this build tool uses to compile your tests, and the JDK it uses to run your tests. And, as good engineers, we all compile our code with all the warnings enabled and treat warnings as errors. And so if the Java compiler in the JDK ends up adding new warnings, all of a sudden your compilation would break and you would have to fix that first. But that's typically not what you really care about. You first want to know whether your code will encounter any regressions when you move to the new JDK versions a couple months down the road. So that's why you want to really separate these things out. And Apache Maven, for example, has a concept of toolchains, where it lets you configure different JDKs for compilation, for running individual plugins, and so forth. Gradle has similar ways of doing things. I think Bazel as well. So depending on the tool of choice, there are ways to make this work. But of course, there's also the simpleton way, which is how I do it. You first build the code using the JDK you run on. So for example, 13 now, you build and run its tests using JDK you run on. Everything passes, you're good, awesome. And then you switch Java Home around to the next early access build of the next release and rerun the tests with that. And if there are regressions, well, that's something you want to look at. And that means you can focus your attention on the parts of your code where something may actually be going wrong. It may be a configuration issue, maybe a JDK issue, it may be in the libraries in the code, but it's something that lets you focus on the parts of the migration that are relevant in this case. Now with the 6-monthly cycle, it means one release ends, the other one comes along, there is no overlap. And some people find it very scary, of course, because they may only start to look at the releases once they're actually released. And I would argue that you should be doing that much earlier than that if you want to benefit from this fast cadence. You should be testing early and often. We start to publish Oracle OpenJDK early access builds as early as 9 months before its GA date. And so, for example, the builds for 14 have started to be published in June, 3 months ago, and 14 isn't due until March. And so that means you have a lot of time to actually put this in your CI system and run your code on it and figure out if there are regressions in this code base. In particular, if you have, dozens or hundreds of dependencies, it becomes increasingly important to test early, because if there's an issue in a dependency, you don't want to be finding out about that a week before the release or a week after the release of 14. You want to find out about that as soon as possible so that those dependencies have a chance to publish an update that, for example, addresses regression, or if it's a JDK issue, we have a chance to fix that before 14 ships. That's why testing early is important. And I would say if you don't want to spend too much time testing, you really should at least test by the time of the release candidates. So that's typically 3 months before release, but 14 is going to be December. And that's when you need to, at the latest point, start to look into how your code would behave on next version if you're adopting the fast cadence. And we provide those builds on a weekly basis for Linux, Windows, Mac, as well as Docker images, so that regardless which system you use, you can easily pull them into your environments and do so. Now, one typical scenario we see is that people may want to use the latest version for its performance benefits, but still compile code and build it for older releases because their customers are on it. So typically, I want release 13 to build my code and run the tests because it's faster, but I still want to be able to build this stuff for 8 because that's what my users use. And there are 2 ways to do this. One is what I call the mediocre way, which is you install JDK somewhere on disk, and then you pass on the corresponding path to the RT or jar file to javac on the boot class path, so it will know the method signatures to link to for the corresponding release, which works, but it has the catch that you then have another JDK somewhere on disk you have to care about, maybe update depending on company policies. So it's not ideal. Since Java 9, there is a new release flag in javac that basically means the javac brings along knowledge about APIs of previous releases from 7 till 13, and so you don't have to install separate JDKs to get the same effect. If you say javac release 8, it will compile for 8 with the right APIs, and that will just work. Yeah.
Do you know if there's some work in progress to make that metadata format a bit more, let's say, predictable or specified? That's something like we have to learn engineer
right.
some thought in order to make it work for us.
I'm not aware of anything in this area, but I'm also not working on that code base, so that may be an issue to raise on compile dev, because I think it's a very useful feature for tool developers. Okay. Okay, so the next part is JDK releasing faster means that things change faster, and one way we signal change is through deprecation. So by annotating classes, interfaces, packages, methods with deprecation annotation, we can tell users you maybe shouldn't necessarily be using this functionality anymore for new code. And that's in some way easy because your compiler will warn you when you use deprecated code in your own code. It'll emit a warning saying using deprecated classes, methods, whatever. Great. But if you're using third-party libraries, they're already binaries. So you can't necessarily get the source code easily to look into them. For that, we provide a tool in JDK called jdeprscan. And what this does is it analyzes the bytecode statically for usages of deprecated API elements. And so, for example, when you run this tool on commons.io something jar, it'll tell you that commons.io overrides finalize and does a bunch of stuff like that. Now, that doesn't necessarily mean this is a problem, right? Functionality is deprecated, but there are different degrees of deprecation. The one you need to be worried about is when something is deprecated for removal. That means that functionality will, at some point in time, go away from the JDK. And so the libraries requiring some functionality will need to be adjusted. And so in this case, we can run the tool again on commons.io, and we'll find out, okay, nothing it uses that's deprecated, it's actually slated for removal in 13. But you want to do this again for 14 and 15 and so on. So you should make jdeprscan part of your CI toolchain to look at the libraries you use when you start using the early access builds of the next JDK. Now, the other part that's important here is looking at libraries that use internal facilities of the JDK, which they may not necessarily be using wisely. So in some cases, we have internal packages like sun, misc, unsafe, don't touch this, that are reasonably clearly named to indicate that things are supposed to be JDK specific, and people use them anyway. In other cases, it may not be so obvious. And there may have been good reasons to do so, say in JDK 1 or 2 or 5 days, but then over time, JDK acquires new APIs and facilities that obviate the need to dig into the inner bowels of JDK, and you can instead use standard APIs. Because those internal APIs can and do change over time. We reserve the right to fix our internals, and that would mean in this case that such code using those classes that are no longer there, for example, or methods, then breaks. And to detect such usages, we have a tool called jdeps since JDK 8. It also statically analyzes the bytecode of jar files and lets you know, for example, in this case, I have something called logback classic, and it depends on JDK internals. Great. It uses sun reflection in one of its classes. So you get output, it tells you where to look for more information. It tells you that this particular API has a replacement since Java 9 that the code could be using instead. And so, you can go and change the code yourself. You're a developer of it. You can file a bug against it. Oftentimes, we find that then people say, well, if I use this new functionality, then I have to move to Java 9. My user's on 8. What can I do? In this case, the answer is you can use multi-release jar files so that you can have one jar file that works both on 8 using the old way of doing things. That's not so good. And at the same time, the same jar file has a separate path for code from 9 and above using the new way of doing things that's then safe to use with future releases. And again, here the recommendation is to start looking at dependencies early and to use jdeps from the latest versions. jdeps, though, can only help you in a static sense. If you're looking at popular code out there, it'll do interesting tricks and things at runtime, dynamically, through reflection. And you can't check that by looking at the bytecode alone. You have to look at the runtime behavior. That's why the Java command line tool, when it detects access to JDK internals dynamically, will print out a warning saying, an illegal reflective access has occurred. Use illegal access warn to learn more about it. So, for example, when you run Java with Groovy 2.47 and ask it to output its version, it'll output its message, and you may be going, well, that's weird. So you enable, the warn flag, and then Java will tell you, well, it tries to access, finalize and clone and object register natives, whatever that is. That's not part of the object API, and a bunch of stuff like that. It still works, but because those are JDK internals, they can change, and in particular because access to JDK internals tend to be limited over time, and maybe denied in the future, it is something you want to be very careful about. And there is a flag you can pass that's called illegal access deny, which shuts such access off. And this is a useful flag to use in your regression tests. So as you can see what impact strict denial of JDK internals would have on the code. But what's often the best solution here is to upgrade the latest version of dependencies. For example, Groovy 3, that's currently at release candidate stage, doesn't have this problem. So its developers have addressed this and looked at it and thought, yep, we should fix this. And they've done so. Okay, so much on the code side, right? So there's a bunch of tools in JDK that help you evaluate dependencies and make sure that you can have a sense of the risk of going from release to release. But there is a bit more to it than just code. And one thing that I think finds a bit too little attention in the ecosystem is javadoc, because we all write documentation, right? Yes. I'll take the one yes as for the whole room. And so that means we use javadoc, and javadoc too changes over time from JDK release to next. And so we have added a tool in Java 8 as part of javadoc, a doclet called doclint, which, following tradition of naming things linked, to do static checks, goes through your javadoc source code and performs various checks on it. For example, whether the HTML is correct, and it does so in a very almost German way. So it's very strict. In line with recommendations for HTML4, and in particular HTML5, so it'll warn you about missing close tags and stuff like that. But it does a whole bunch of other things as well, like checks for accessibility, which can be an important feature if you're looking to enable developers to access the documentation who may not be able to experience it the way that you do. And so this doclint tool is on by default in javadoc since 8, and you can turn on all of its checks, or of course you can say, I don't care for now, and you can turn them all off. And some people do that. And I would recommend not doing that anymore, because again, javadoc changes as well. So for example, doclint was introduced in JDK 8, and then that was about 5 years ago, about a time when HTML5 came out. And then in JDK 9, javadoc got HTML5 support. That was 2 years ago. In JDK 11, HTML5 output became the default in the JDK. And this year, so now with 13, HTML4 support has been removed from javadoc. And so, if you keep ignoring these warnings and errors, then you might find yourself again having to go through a larger amount of work than would have been really necessary if you go through this gradually, piece by piece. And since javadoc also evolves on this expanded cadence, I would also recommend looking at the warnings generated by it in your code bases. What the doclint plugin does, though, is limited to the source code you feed it. It's the standard doclet. And many of you may be using other third-party doclets to generate documentation, so that javadoc doesn't see it or doesn't see all of it. And so doclint wouldn't be able to catch necessarily all the issues in it. And so we have a separate tool called doccheck. This one is not part of JDK. It's available separately as part of the OpenJDK Code Tools project, where we have a number of such small tools that do various things around JDK development. And what doccheck does is perform the checks from doclint on the generated HTML documentation. So you can run that after you run you're building your CI system using third-party doclets, and it'll do the same checks for HTML correctness, in particular HTML5 correctness, accessibility, and it'll do a bunch of other things as well, like it'll check for external links, legal notices, and so forth. And so this is another useful tool to have in your repertoire when you're embracing the faster release cadence, because it can help you detect issues that you otherwise wouldn't be able to necessarily find. So, and last but not least, I'd like to reiterate that all of this stuff is available way before release. So right now we have JDK 14 early test builds every week, and they'll continue to come out every week until release candidate phase in December, where all of that slows down a bit. Because once we start ramping down in December, then we start focusing gradually on higher and higher priority issues, of which typically there is less and less. And one of the interesting things about a fast release cadence is that also we've not only noticed that we're able to release on time, we've also noticed that our releases are, more predictable. So the number of release candidates has gone down to 1 or 2 at best in those short cadences. And so that also means that what ends up being shipped to users at GA time is really ready to be used. So I recommend, that you start looking into testing with 14, 15, 16. If not now, not this year, start looking at it next year, because 17 is going to be next LTS release. And so that means all what I've said so far doesn't just apply from one JDK release to next, from 12 to 13, 13 to 14. It also applies if you're moving from, say, 11 to 17. But if you start now, you have years to basically work out the kinks. If you start 2 years from now, you have more work ahead of you. And we also provide all these builds for the various tools we have, projects we have like JPackage and Valhalla and Panama and so forth. More about that, though, tomorrow at 5, I think somewhere around here. Thank you very much.